Well, good morning or good afternoon, everyone, and welcome to this special webinar where we're going to be talking about some of the fundamentals of collaboration technologies. Now, I know some of you maybe just have an interest in getting into Cisco Collaboration. If so, this session's for you. We're going to discuss a lot of the fundamental concepts surrounding voice over IP, video over IP, some of the different communications options that we have out there. We'll talk about different servers, voicemail servers, messaging servers. There's going to be lots of cool things coming up today, and I'm really, really glad that you took the time out of your day to join us. I've been asked, how long is this going to go? I honestly don't know. I've got a certain amount of content. It depends on how interactive we get, how many questions you guys ask, you guys and gals, and really excited to get going here. I kind of like to know as we're getting going here, and I'm seeing some hellos come in. I'd love to know where you are joining us from. So if you just want to chat that into the comments area, what part of the world are you joining from? I love it when we have these global audiences. Let's see here. Yeah, we've got. I had somebody tell me that they were coming in from Zimbabwe. Yeah, somebody said the video is really small. You know what? Yeah, I'm going to be toggling back and forth between the video and the slides. So right now, I'll go ahead and go full screen for you. But we'll get into the slide content, and I'll minimize my video here in just a minute. We'll bounce back and forth. We got people coming in from Germany, from Baltimore, Maryland, Washington, D.C., Missouri, Florida. Awesome, love it. Hey, thanks for the interaction, everyone. Really do appreciate that. Belgium, we do have a global audience today. Looks like we've got about 31, and I'm expecting that's going to continue to grow over the next little bit. So let's jump into the content. I'll minimize myself again as we take a look at some of the slides. So let's see if I can get that launched. 1 second while I do that. Let's see here. That is not launching for me. I'll turn my camera off real quick. And you should be seeing me minimized in the corner right now as we get into our content today. Now, I appreciate you telling me where in the world you're coming from. Another question I have is, what is your level of experience with Cisco Collaboration networks? Is this something that's brand new to you? Are you just considering it? Have you already started going down the collaboration track? What are your goals? Just give me a sense for what you're here today. Just curious about collaboration. Are you already involved in the discussion of collaboration? You've already started taking some of the exams, started doing some of your studies. Oh, we've got somebody studying for Jeffrey studying for the CCNA Collaboration Lab. Awesome. That's got to say, everything I've done in my career, that was the most challenging thing I've done in my entire career. Okay, we got somebody here with about 8 years of experience. That is fantastic. That is awesome. So it looks like we've got a wide range of experiences today, and that's great. Let's do this. Let's jump in, and we're going to start with the basics. We're going to talk about something that Cisco recently removed from the voice/collaboration curriculum, and it's just some of the fundamentals of traditional telephony networks. And since we're moving from a traditional telephony network to modern day telephony networks, it's kind of important that we understand where we're coming from, so that we can say what are the equivalent solutions with Cisco Unified Communications and some of our different collaboration options. So let's start talking about just a traditional telephony network. We'll do this real briefly, and then we'll get into the collaboration content. First, some acronyms. There's going to be a lot of acronyms today if you want to take some notes on this. The first acronym is the PSTN, the Public Switched Telephone Network. Now, this is the traditional telephone network. If you've got a landline in your home and you're connecting back to your telephone company and you're calling your relative across the country, well, you're connecting and you're calling through the PSTN, the Public Switched Telephone Network. And the way we traditionally connected to that is we have a phone in our home, and that home phone is going to connect in using something called it's called a local loop. If you go outside your house, you might see those that box that the telephone company is mounted on the side of your building, and you've got these wires going from your house all the way back to the telephone company or to some other equipment they might have in your neighborhood. So another term for you to put down in your notes is the local loop. Now, little pop quiz, because I know we've got some people with some experience here. And the little pop quiz question for you is, can somebody tell me the names of the two wires that carry our voice and our voice signaling on a traditional phone? It's two wires, one's red, one's green. What do we call those wires for those of you that have been in the field for a while? What do we call those two wires? Yeah, Jeffrey first one in with correct answer. That's our CCA candidate. So no surprise, Jeffrey came in on that. Diarra. Yeah, we've got lots of correct answers coming in now. Tip and ring. Exactly. We've got these two wires, and these two wires carry both the signaling, like the ringing, as well as the actual voice itself. Now, we also have businesses connecting through the PSTN. So in our businesses, we might have analog phones connecting into a PBX, a private branch exchange, which is a privately owned phone system. For example, I used to work at a university, and the university had, I think we had about 6,000 phones on campus between the faculty and the staff and the students, but we only had about 200 lines coming in from the central office. So 6,000 phones, 200 lines. Why didn't we have a line for each phone? Well, that's the reason they bought the PBX. They wanted their own phone system because statistically, not everybody's going to be on the phone at the same time. What we can do is share those lines going back to the central office, coming from whoever among those 6,000 people are going to be making a call or receiving a call at the moment. You can do these traffic studies to understand approximately how many lines you need to handle your busiest time of traffic, your busy hour, it's called. And so we didn't have to spend the money to get every single phone, a phone line back to the central office. We just connected into a PBX, and then we had other locations on campus. And we had other campuses, other cities in the state, and we connected out to those devices as well. Now, when a PBX connects back to the public switch telephone network, it's not called a local loop, it's called a CO, a central office trunk. Because this trunk line, typically it's a digital line of some sort, and it's going to be able to carry traffic for multiple phone calls. For example, a T1 circuit, depending on how we have it set up, it might carry 23 simultaneous calls. It might carry 24 simultaneous calls. Again, just depending on how we have things set up. Now, just a few more slides on the traditional telephony network, and then we'll jump into the modern stuff. But with traditional telephony networks, and we still have this today, we have signaling, different types of signaling. We need signaling to let us know that somebody's busy or somebody is their phone's ringing. We get that feedback in our ear, the ringback tone or the busy tone. Now, signaling is going to be a phone ringing to let us know that we're receiving a call. When we're dialing numbers, that's signaling. Now, let's talk about three different types of signaling. One type is supervisory signaling. Now, supervisory signaling that would include things like seizing a line, going back to the CO. In other words, is your phone on hook? Is your phone off hook? That would be an example of supervisory signaling. Next would be address signaling. Now, address signaling, for your notes, that's going to be when we're dialing a number. Now, there are two primary ways of dialing numbers, and we're going to talk about both of those today. But one more type of signaling first, and that's information signaling. This is giving us information back, like our phone's ringing. I must be getting a call. That's information. Or I call somebody. I call my wife, and I hear a busy signal. Or I go to her voicemail. Well, that's some information coming back to me that she's not available for the call right now. Now, let's get more specific about some of these different types. First of all, let's answer a paradox that comes up a lot. Let's answer the question, when a phone is on hook. In fact, I've got a really old phone I was going to show you something with later, but here's a really old phone. In fact, I think this thing is older than I am, but this is an old rotary phone. And if I take the handset off hook, there's actually a circuit that's closing inside of the phone to allow current to flow through. Because when the phone's on hook, I mean, there's no dial tone coming through the receiver because that circuit is open. So if I've got this circuit physically open when my phone is on hook, here's the paradox. How can ringing voltage come through this circuit if the voltage that gives me my dial tone and actually lets me hear the other person, that's not coming through? Well, here's the answer to that. I drew out a simplified schematic of your phone on screen. That switch that I said gets closed when we go off hook, it's called a switch hook, or some people call it a hook switch. Either one's correct. And that is going to only pass current when we're using direct current. Back at the central office, there's a battery, a 48-volt battery on your tip and ring lines, and it starts to send loop current through your phone once you go off hook. But again, the question is, if the circuit's open, how do I send ringing through this guy? How do I send ringing through the phone to make the ringer ring? Well, notice on the little topology I gave you there, the schematic, that the ringer is in line with a capacitor. Now, if you've studied electronics much at all, you know that a capacitor is going to block direct current, but it's going to pass alternating current. That's the secret. The alternating current is what ringing voltage is using. It's going to be on the order of about 90 volts to about 120 volts. You can feel it. If you've ever accidentally been fooling with the tip and ring wires and a call comes in, it certainly happened to me, you're going to feel it. It's like a shock. It's like, ow. It's like 100 volts or so coming through there, and it's alternating current. So we're going to have alternating current letting us know that, hey, the phone's ringing right now. It's going to make the ringer ring, but we're not going to have that current going through the handset yet because the handset's off hook. I mean, or on hook. That circuit is open. But as soon as I go off hook, that circuit closes, and then I'm able to send the direct current through the handset like this. And it's going to power my transmitter, and it's going to power my receiver. Now, another type of signaling is address signaling. This is where we're going to be dialing numbers. Now, the reason I brought out this old phone today was that this is the way that we used to do address signaling. It was, remember the tip and ring circuit, that if I go off hook, it's closed. If I go on hook, it's open. Closed, open. Well, one way of dialing a digit is to very rapidly open and close that tip and ring circuit. For example, I'm going to go off hook, and if I dial the number 0, I put my finger and I rotate the 0, and you might remember how this sounds. I'll put it up close to the microphone. And I just dialed the number 0. When I did that, here's what was happening in the background. Or I think in this animation, I'm using the number 3. So I'll dial a 3. Here's what's happening. When I go off hook, that circuit becomes closed. So that's first we see that we go off hook. Then I dial a digit. And I dial the digit 3 just now. And what it's going to do very rapidly, it's going to open and close, open and close, open and close that circuit. But it's going to do so quickly that the phone switch back at the central office or the PBX at our local company, it's not going to think that we went on hook. It's going to realize, oh, that's a dial number. Kevin just dialed a number. He dialed the number 3. And if you obviously close the circuit too long, it's going to think that you hung up. So you don't want that to happen. So these have to, the measurements are very specific about how long you're on hook, how long you're off hook. But just for fun, I remember that my dad used to work for a local telephone company. So I got to hang out in the central office a lot as a kid. And I remember he showed me how to dial numbers without ever using the dial. He showed me that I could just take my phone like this and just very rapidly tap the hook switch. So I used to call my friend that lived down the road from me. If I wanted to dial a 6, I would do that real quick, and it would dial a 6. That was legitimate information signaling, and that still works today. But it takes quite a while to do that kind of signaling, so we rarely use it these days. It's supported on your Cisco routers. You can have ports that will understand pulse signaling. It'll be able to generate pulse signaling, because maybe in some parts of the world, that's what the telephone equipment is using. You want to be compatible with that. But typically today, we're going to use a series of tones. Now, these tones are called DTMF, dual tone multi-frequency tones. And when we dial the number, I gave you an example on screen. If I dial the number 5, I press 5 on my telephone keypad. What it's doing is it's simultaneously generating a couple of frequencies. You see on screen, it's going to be generating the 1336 hertz frequency and the 770 hertz frequency, and it does them together. You might wonder, why don't we just have one tone for one number? Background noise. You could just have some sort of frequency happening in the background, and that could be inadvertently thought of as you're dialing a digit rather than just some background noise. In fact, I remember talking about these tones. I remember between central offices, I heard a story one time of these phone switches that were connected between central offices, and they use something called SF signaling, single frequency signaling. And as long as there was this particular frequency on the line, then the phone switch thought the circuit was idle, that nobody was using it right then. And there was this one woman I remember that had sort of a monotone voice, always talked in this tone, didn't really vary her frequency very much. And when she would speak, it matched that frequency. She started to talk and click. The phone system hung up on her, but we don't have those today. Just kind of a funny story from the past. Now, these DTMF tones that we use to dial digits aren't just used for dialing digits; they're used for information signaling as well. So not just for address signaling, but for information signaling, like a dial tone. Did you realize dial tone is a DTMF tone? It's a simultaneous generation of 350 hertz and 440 hertz. The ring back when you hear somebody, when you call somebody and you hear it ringing in your ear, that's DTMF. Busy signal, the reorder tone. That's those are all examples of dual tone multi-frequency. So now, kind of a quick review of traditional telephony networks where we had all these analog connections. We had PBXs, and companies spent a lot of money on those PBXs. If you want to start to migrate a company from a PBX environment to a unified communications network, it's probably not going to be an over-the-weekend upgrade. You might need to do that in phases. So I wanted to make sure you understood the legacy stuff before we got into the new stuff. So let's start talking about how we might take some baby steps. What would be our first step? We go into this company like we see on screen. They've got existing PBXs between a couple of locations. They've got analog phones going into those locations, and they want to do voice over IP. You see, right now, they're paying for a WAN connection between their sites for their data, and they're also paying for the CO trunk lines for their voice between their locations. Well, instead of paying for two separate lines, wouldn't it make more sense if we just sent the voice and the data and perhaps even the video over the WAN? So check it out. Here's what we can do. We can get rid of the CO trunks, those tie lines, and we can connect the PBXs directly into our Cisco routers. And those Cisco routers can communicate over the IP WAN, and that can be the connective tissue that ties our PBXs together at our different sites. And as a result, we start to save money right away, and we're doing voice over IP at this point. We've got IP packets traveling over the IP WAN that's carrying the voice. Now, here's another term for your notes. It's the protocol that carries the voice with voice over IP. It's called RTP, the real-time, that's real-time transport protocol. RTP is the real-time transport protocol. And that's a way that we can start to get a company moving towards voice over IP. Now, when we're connecting into a PBX, there's different ways of doing it. One way is that PBX might have some digital ports. Now, if you would just type in, what is an example of a digital port that we might find on a PBX? Go ahead and just chat that into the comments area if you would. What sort of digital ports we have? I'm thinking of two answers. The first answer I'm thinking of is something like an ISDN connection, Integrated Services Digital Network. I'm also thinking of like a T1 circuit, maybe a T3 circuit. But we've got a digital circuit that can carry multiple simultaneous conversations. Yeah, we've got the first answers that came in from Jeffrey and Dennis and are saying PRI. That's a type of ISDN circuit. That's a primary rate interface. That's our ISDN circuit that's built on top of a T1 or perhaps an E1. So we've got digital options. That's great if we have that. But sometimes we don't have that option. Sometimes we might need to connect into an analog port in our PBXs. And there are 3 analog ports that I want you to know about that we can install in our Cisco routers. And I've got them listed for you here on screen. The first one, and please take some notes on this. The first one is FXS. That stands for Foreign Exchange Station. And the Foreign Exchange Station connects to, here's the memory aid for you. A Foreign Exchange Station port connects to a station like a phone. You could take this analog, I've done this before. You can take this analog phone and you can plug it into an FXS port and it will generate ringing voltage to ring the phone. If it goes off hook, it will play dial tone to the phone. It will understand dial digits coming in from the phone. So we can use an FXS port to connect to a phone. But if we want to connect into something like the PBX, we might use the Foreign Exchange Office, the FXO port. But again, the memory aid is FXO, Foreign Exchange Office, connects into an office like a central office. It connects into some sort of an office switch, a phone switch, like a PBX, like a key system at a lower end, or like the central office. So you might connect that into your PBX. And it acts kind of like a phone. The central office can ring into that FXO port, and that FXO port can answer. That FXO port can go off hook. It can dial digits itself like a phone would do. But typically, if you're using analog circuits with a PBX, typically you're going to be using the bottom option. It's an E&M port, it depends on what literature you read. Some literature will say that E&M stands for ear and mouth, earth and magneto, the E in receive and the M in transmit. Personally, I'm an ear and mouth kind of guy. That's what because think about it. If you actually look at the E and the M leads that do the signaling, it works out like this. The E lead is used for receiving. So you're listening on your ear, your E lead, and you're transmitting with the M, your mouth. So that's the way I like to think of it. And these ports, again, one call per circuit, one call per port. But these ports are analog ports that we could use to connect our router into our PBXs. Now, as we're doing this, as we're coming out of our PBX using maybe an analog circuit, we need to take these waveforms and convert them into digital. We need to convert them to ones and zeros. You see on screen an example of an analog waveform, a continuously varying waveform. And then we see at the bottom a digital waveform, something that is, we have very discrete measurements. We've got it's on or it's off. We've got voltage on the line or we don't have voltage on the line. By the way, just a side note here, when we're sending digital signals, ones and zeros over copper cabling, here's the way it typically works in the telephony world. Notice that if we have zero voltage, that's that baseline there. Zero voltage represents a binary 0. And the presence of voltage represents a binary 1. And you'll notice that sometimes the voltage is up above the line. Sometimes the voltage is down below the line. In other words, sometimes it's positive, sometimes it's negative. And here's the reason. We're trying to achieve a certain electrical characteristic on the wire. You see, on average, we want to have 0 volts on the wire. So we can have half of the voltage as being positive, half of the voltage as being negative. So on average, we've got 0 volts on the wire. And I've taught this concept for 16 years. And I've tried to come up with a metaphor to help my students understand. Here's the best metaphor that I've seen or heard. Let's say that I take one of my hands and I put it in a bucket of ice cold freezing water. And I take my other hand and I put it in a bucket of boiling hot water. Well, on average, I'm going to be comfortable. Okay, it doesn't work like that way for humans, but that is the way it works with with electricity. We have an average of 0 volts on the wire, and we want to take this continuously varying analog waveform, and we want to represent that as ones and zeros. So let's ask the question, how do we do that? Well, what we can do, you see, I've got this waveform shown for you on screen with all these dots. What we can do is just take some snapshots. We can take some snapshots of these dots on screen, and we can say, here's the voltage at this point. Here, and it's a positive voltage or it's a negative voltage. And if I take enough samples, if I measure the polarity and if I measure the magnitude of the voice or the voltage, then I can approximately represent that digitally and get it played back digitally. Now here, and one of our students was pointing out that it's called sampling. Yeah, this is exactly what we're doing. We're doing sampling. Now we can do undersampling or we can do oversampling. So let me give an example of that. If I don't take enough samples, because what we're doing is we're playing connect the dots here. If I just take 4 samples with this waveform that I have on screen, and I say, I want to take a sample here and here and here and here, and then to play it back, to convert it back into analog so I can play it out to the listener on the other side of the conversation, if I connect the dots, look at the waveform we get. It looks nothing like the original waveform. This, another term for you, this is called an aliased signal. An aliased signal. It's an incorrect signal because we did not take enough samples. This is called undersampling. Now, you could take lots and lots and lots of samples like I showed you on the previous diagram. That's called oversampling. And yeah, the more samples you take, the better the voice quality is going to be. But there's a trade-off. We got pros and cons here. The con is if I take too many samples, I'm using bandwidth. It takes bandwidth to send the data of each of those samples. So we don't want to send too many samples. But there is sort of a magic number. There was a man named Harry Nyquist, and back in the late 1920s, he worked for AT&T. He also became a college professor, and he gets credit for it, but he worked in collaboration with 1 or 2 other people, and they came out with this paper on sampling. And he came up with something called the Nyquist Theorem. The Nyquist Theorem. And the Nyquist Theorem states, and you might want to jot this one down for your notes, the Nyquist Theorem states that if I want to accurately represent an analog waveform digitally, the minimum number of samples I can take more, but the minimum number of samples I can take equals, here's the formula, the minimum number of samples that we take equals 2 times the highest frequency. 2 times. So if I were trying to, now the human ear can hear around at the high end, it can hear around 20,000 hertz, 20,000 cycles per second. So if I wanted to produce something that humans, well, I should say younger humans, children and maybe younger teenagers, before as we age, that frequency response of our hearing goes down a little bit. But younger humans will say, if we wanted to give them super high fidelity sound, we could take, let's see, 2 times 20,000. We could take 40,000 samples a second. That's a lot of bandwidth. Now we're doing that these days when we're streaming these movies like on Netflix or Apple TV. You bet we're taking a bunch of samples. That's high fidelity sound. But here we're talking about phone calls. And it was discovered long ago that statistically, the human voice has 90% of its voice intelligence. In other words, the frequencies needed to understand what the other person is saying. 90% of those frequencies occur below 4,000 hertz. So when you're talking to somebody on the phone, you probably have noticed that it's not like listening to your earbuds when you're listening to your MP3 player. It's the fidelity is just not there. It's a little tinny. It just doesn't sound as rich as an actual conversation does. And that's because for phone calls, we're only shooting for about 4,000 hertz at the top end. And we're shooting for about 30 hertz at the low end. 300 hertz at the low end. What's between that? That's 90% of our voice intelligence, roughly. So let's ask the question, and you tell me, chat it in. If I'm, yeah, Jeffrey's saying that Jeremy Charles calls it the Nyquist theory. Yeah, actually, funny story. Yeah, Jeremy and I, we used to teach this content together back in 2000 and 2001. He came up with that as I was teaching the same concept. I think in about 2001. He interjected that he was my co-instructor. Yeah, he came up with that during one of the classes that I was doing. He called it the Nyquist theory because he was saying that it puts a lot of people to sleep when you talk about it. But yeah, that's kind of a funny way to remember it. Now, back to our point. The question I want you to answer is, according to the Nyquist theorem, if I'm taking 4,000 samples per second, I'm sorry, if my highest frequency is 4,000 hertz, how many samples per second should I take? How many samples per second should I take? Go ahead and chat that in if you would. While I take a swig of my Diet Snapple. Yeah. Seeing the correct answer start to come in. It's 8,000 hertz. Well, careful with the units of measure. It's not 8,000 hertz. It's 8,000 samples per second. The frequency is 4,000 hertz, but the number of samples is, we've got lots of people coming in with the correct answer now. It's 8,000 samples per second. Now, the next question is, now that I'm taking these, I think I'm going to the movies. If you go to a movie, probably the next one I'm going to go to is Star Wars Episode 8. I've already got my tickets. I've already purchased my tickets for opening day, so I'm excited about that. And when I go sit down in the movie theater and I start watching that opening crawl on the screen, I'm going to be viewing 24 frames per second. At least typically that's what movies use. I'm going to be viewing 24 images, one after the other, and there's going to be 24 of those in a second. So they're still images, but if I'm looking at them really, really rapidly, to my eye, it looks like smooth motion. And it's the same thing with audio. If I take all these samples of audio and then play them back really, really quickly, it's going to sound like smooth audio. So the question is, okay, we've decided I'm going to take 8,000 samples every second, and I'm going to represent those digitally. So the question is, how do I do that? How many bits are we going to be using to do this? Because you get the picture here. We're going to take this analog waveform and we're going to measure the polarity. We're going to measure the magnitude of the voltage. We're going to basically say it's this much voltage and it's positive. That could lead to an issue. Let me explain the issue that we could run into here. The issue we could run into is something like this. Let's say that we start assigning these numbers. We're saying if it's a really low volume, it's going to be the number 1. If it's a little bit higher, it'll be a 3, and then on and on and on. We can have these numbers spaced out like this. And then if we look at the actual voice, we look at the actual voice amplitude, the volume, you'll notice that none of them that I have drawn for you on screen, none of them perfectly matches up with one of the numbers. Nothing matches up with one of the numbers. In other words, none of them are perfect representations of what was actually said. You see that little delta there? I'm showing you little brackets, and I'm showing you there's a gap there, that delta causes something called, well, the delta is called quantization error. Quantization error. Now, the result that we get from that as we're listening to it is we hear, it's sort of like static in the background. It's called quantization noise. So there's a problem if I don't take more accurate samples. Now I could use 256 bits to represent every sample, and I could be pretty accurate. There wouldn't be much quantization error, but you know what? We're going to use 8 bits, just 8 bits to represent each voice sample. And we've got some rounding off. We've got some error here, but we can improve on this by using, instead of a linear scale like we see here on screen, we can instead use a logarithmic scale. Do you remember, were you ever in school and took a math class where you had to have the log graph paper where you had the lines are really close together and then they're spaced out a little bit more? It's like factors of 10 every time you go up one major line. Yeah, what we're doing there is we're taking more accurate measurements with the lower numbers. So that's what we do with voice. We don't assign numbers based on a linear scale. We assign numbers based on a logarithmic scale. And I'm just showing you kind of a small snippet of that right here. We have what are called segments and steps. We take the y-axis, if you will, and we chop it up, and within each of those little segments, we create these individual measurements called steps. So we're being more accurate at the lower volumes. Now, this gives us two benefits when it comes to voice quality. Benefit number one is most of our speech occurs at the lower volumes. So we're being more accurate for more of our samples. A second benefit is for the higher volumes, they're so loud anyway, they tend to drown out the quantization noise. So we're just going to use 8 bits per sample to measure polarity and then represent the segment it's in, represent the step it's in. But we can be more accurate if we use a logarithmic scale. So here's the way the 8 bits fall out. We've got 1 bit that says, what's the polarity? Is it positive or negative? Then we've got 3 bits to say, which of 8 possible segments is it in? We've got it divided into 8 segments. And the lower segments, they're packed. They have their steps packed much more closely. And within each of the segments, we've got a possible value of 16 different steps. So we've got all these discrete measurements we can take, and we're going to round off to the closest one, and that's going to give us our 8 bits. So let's do some quick math here. A bunch of you are about to have a light bulb moment. Are you ready for this one? We're saying that if I take 8 bits per sample, and according to the Nyquist Theorem, I'm taking 8,000 samples per second. So 8,000 times 8 is 64,000 bits per second. That's a familiar number, isn't it, in the telephone world? That's the size of one of our channels on a T1 circuit or an E1 circuit. If we're doing uncompressed voice on our Cisco IP phones, the codec that we might be using G.722 to do this. We might be using G.711. But by the way, a codec, that's a coder decoder. That's the way that we don't always compress, but that's the way that we're encoding the voice. Now, G711 does not do compression, and it takes 64 kilobits per second based on the diagrams that I just walked you through, and we saw exactly how we came up with that rate of 64,000 bits per second. Now, when you go over a slower network, maybe like a wide area network, you might want to be a bit more conservative with your bandwidth. You might want to sacrifice a little bit, not a lot, but a little bit of voice quality so that you can get more bits through the wire, or more information, I should say, through the wire. You can have more simultaneous voice calls without upgrading your WAN bandwidth. So you might use a codec like G729. Now, if we're just talking about the payload only, we go from 64K down to only 8K. Yes, we sacrifice a little bit of quality, but it's generally not bad. Now, you don't want to play music on hold using G729. That sounds bad. But it's designed for Latin-based speech patterns. So it's pretty good. It's pretty good if you're just using it to talk with. So no big concerns there. Now, it's not just voice over IP that makes up this collaboration world. It's also video over IP. For example, we might have somebody with their tablet that has a camera on it. Like, see, I've got my iPad laying over here that's got the little camera in the top. I could be sitting there on my iPad and running an application like Cisco Jabber, and I would be able to have a video call with somebody else that maybe is using Jabber on their computer, like we see illustrated here on screen. So we could have these calls going back and forth. So in fact, to kind of give you just a little bit of history on this, I started teaching this voice curriculum for Cisco back in 2001. And back in those days, we had what was called the call manager. And a lot of people still call the server itself, they call it the call manager server. But I started teaching on version 3.0. It goes back quite a ways. But when it got to version 7.0, they stopped calling it call manager and they started calling the server the communications, the Cisco Unified Communication Server, because it's not just calls. Well, I guess it's calls, but it's voice calls and it's video calls. We want to be able to support both. And just to give you some examples how we might use video in our network and some of the components involved, we might have video conferences. Toward the end of our session today, we're going to talk about TelePresence options, where you can have these big, massive screens in these rooms. And I've used them. I'm telling you, it really feels like you're in the same room with the person you're talking to. They're almost life size on this screen, and the audio quality is no 8 bits per sample there. I mean, it's CD quality audio. Yeah, we'll talk about some of those systems. We might just be conferencing between a bunch of video-enabled phones, and I'll show you several of those. But if we are having some sort of a conference, there's an element that we need. We need to have something called a multi-point conference or a multi-point control unit, or an MCU. Now, if you have a Cisco router, a Cisco ISR second generation router, like well, here in my studio, I've got a bunch of Cisco 2911s, and each of my 2911s have what are called PVDMs, packet voice DSPs. We've got these basically they're chips on this little circuit board that we plug into the router's motherboard, and they're in charge of doing the heavy lifting when it comes to manipulating packets, when it comes to like converting from a circuit coming into the router, converting that into IP packets. If we're doing transcoding and we're converting between codecs, those PVDMs, the packet voice DSP modules, packet voice DSP modules, they're going to do that lifting for us. Now, if you have a PVDM3, and the reason I bring it up is this is a requirement, you need to have a PVDM3 in order to do video conferencing. If you have a PVDM2, like on a first generation ISR router like your 2811, sorry, it's not going to work. In fact, here's the minimum. If you want to have a video conference set up using your router as this conference bridge for your notes, this is the minimum. You have to have at least a PVDM3-128, because you can get PVDM3 32s and 64s and 128s and 256 and all. You got to have a 128. Can you have 2 PVDM 64s? No, it seems like you could, but no, it has to, a minimum, you have to have a PVDM 3 128. And some of the applications that we might have for video include things like telemedicine. Oftentimes we have medical specialists. They're like one of the top people in the world at this particular condition, and they're not going to be able to fly across the country to look at some other doctor's patient, but there are telemedicine applications with extremely high resolution where they can pull up MRI results and X-ray results. They can have face-to-face conversations. They've even got where they can operate remotely with these robotic arms, and they're able to see over the video stream what's going on with the operation. It's incredible. Distance learning is kind of what we're doing now, even though my little video is minimized on screen. You're seeing my video as I'm doing this little Facebook Live session for us all. Another one you see, and there's lots of examples. These are just 3 that came to mind. Telejustice. This is getting really common in the court system. When somebody gets arrested, instead of having to haul them in from the county jail in front of the judge, there's a little area set up in the jail, I would imagine. I've never been incarcerated myself, but I think there's this little area set up in the jail where they get in front of the camera and they communicate back and forth to the judge, and they enter their plea and so on. So telejustice is what that's called. Now, let's take a big leap in our discussion now that we've talked about the fundamentals. What does a traditional telephony network look like? What does a modern day telephony network, or what are some of the components of a modern day telephony network? Let's talk about the servers that make up a Cisco Unified Communications Manager or communication solution. And there's a bunch of them. So you might want to take some notes on this. And I'll just kind of walk my way down the server. Well, first of all, let's start at the top. We've got an Ethernet switch that connects out to our Cisco IP phones. And that Ethernet switch is nothing really necessarily special about that switch. It's going to interconnect devices using Ethernet connections. And we're going to be able to connect our routers to that. And one of those routers at the top of the screen can be a gateway. A gateway is a translator. A gateway is a translator that's going to convert between one audio or video format into another format. So here, if I want to place a call from our corporate location out to the PSTN, then I could go through a gateway, and it's going to take my ones and zeros. And if it's an analog circuit, it's going to convert that into a varying waveform. Pretty incredible. I didn't tell you all let me go back and hit the rest of the servers. We've also got, and this could be in a router, we could have something called a Cisco Unified Communications Manager Express. Now, I don't want everybody typing in yes or no, but I'm just curious, if you do happen to use a CUCME, a Cisco Unified Communications Manager Express in your network, can you just give me a yes? Just type in yes, that yes, we use a CUCME. Now, this is going to be good for small to medium-sized offices. It's going to cap out, and it depends on what router you get, but it's going to cap out around 500 users, 500 phones at that site. But it's a pretty economical way to have a very robust, I'm already seeing one or two people have that installed in their environment. It's a very economical way to have a robust telecommunications solution. So that's going to be your call agent, the device that's responsible for handling calls, setting up calls, maintaining calls, tearing down calls, converting between, handling the route plans, all that kind of stuff, things that a PBX would do. It's being done inside of a router. Now, for larger environments, we're going to have, and I'll jump down just a little bit for the, well, we've already talked about the multi-point control unit. That's going to be to create conference calls. Next on the list going down, we've got the CUCM. Now, that's kind of the star of the show when it comes to Cisco Unified Communications. That's the Cisco Unified Communications Manager Server. And you're going to find a lot of people out there that still call it the Call Manager Server. Now, the term Call Manager is still valid, but Call Manager is no longer the name of the server like it was back in version 3.x and 4.x. As of version 7.x, it became the Cisco Unified Communications Server. Now, Call Manager, I said it's still a valid term, but it now refers to a service. It's one of many services that runs on the Cisco Unified Communications Manager Server. So I don't know. I'm overly nitpicky about that, but I just kind of cringe when somebody says, "Yeah, I've got a Call Manager server," and I'm like, "No, you don't. You don't have a Call Manager server. You've got a Cisco Unified Communications Manager." Okay, off my soapbox about that. But that's like the star of the show that I was saying. That's what's going to be able to register. Depending on the server and its capacity, you can register thousands of Cisco IP phones and other video devices with that server. And once those devices have registered with that server, they're going to be able to call one another. We can do all sorts of manipulation with the call. We can set up hunt groups. We can set up restrictions as to who can call whom. We can set up conference calls. We can integrate this with voicemail systems. And in fact, speaking of voicemail systems, we can have what's called the CUC, the Cisco Unity Connection Server. That's Cisco's flagship messaging server these days. And I've got another slide or two coming up just on that. But for now, just realize that's their enterprise voice messaging solution. Next up on the list is the Cisco IM and Presence Server. The instant messaging is what the IM is. Cisco IM and Presence Server. Now, instant messaging clients have been around for a long time. Anybody ever use the old Yahoo Instant Messenger? Yahoo had one. AOL had one. It was AIM, the AOL Instant Messenger. There's been lots of those out there where you can just have this little client at your desktop and you type something up and off it goes to one of your colleagues somewhere. Well, that's cool. And you can do that with something called Jabber within Cisco Unified Communications Manager, if you have the Cisco IM and Presence server, because it's going to support instant messaging. But Presence is even a bigger deal, I think, because Presence tells you someone's availability to take a call right now. On your Cisco IP phones, you've got these, they're called BLFs, busy lamp fields, and they're lights, little LED lights. And if it's red next to somebody's directory number that you have on your phone, they're busy. They're not available to take a call right now. Or if you're in your Jabber instant messaging client and there's like a red or a yellow dot next to their name instead of a green dot, you know that they're not available to take a call right now. Now, they might not be available because, they might not be available because they're on the phone. And that can be, when that happens, Cisco Unified Communications Manager sends a message over to the IM present server and says, hey, he's on the phone right now. So the present server says, I'm going to turn the red light on next to their name and everybody's Jabber client. It could be because their Microsoft Outlook calendar said that they had a meeting today. Literally, we can track it to that level. Well, we can say that we have a meeting today, and that's going to make us appear as busy or unavailable during that meeting time. I've got a bunch of slides coming up on that, but that's just a high-level overview. And down at the bottom, we've got Cisco Unified Contact Center Express, which is sometimes abbreviated as UCCX, Unified Contact Center Express. Now, this is going to be used for a call center environment. Now, Cisco also has an enterprise contact center solution when you've got like a major contact center. Maybe you've got virtual workers working out of their homes all over the world. That's really, really high end. But most people that need a contact center, they can use this. It's you almost need to be a little bit of a programmer to do a lot with the Contact Center Express, because you can write these scripts that say what happens. Somebody calls into the main number of a contact. You've done it. You've called into tech support. You've called in to order something, and you get the message like, your call is very important to us. Please stay on the line and someone will be with you as soon as possible. And then you hear this music that tries to, have you ever noticed it's really calming music on those music on hold? I think they try to take upset customers that are waiting and they try to calm them down by playing a little Kenny G or something to them. Just a personal theory. But we're going to have this Contact Center Express that's going to be able to make intelligent call routing decisions. We might say press 1 for IP phone support, press 2 for video support, press 3 for sales. And we can route the call based on what the person entered to different call agents. We can even have different skill levels. Somebody says, okay, I'm a tier 1 person. I'm going to kick you up to tier 2. We can have different skill levels. There's a lot you can do with the Unified Contact Center Express. It is very, very robust. And that's not something you really need to worry about, by the way, at the CCNA Collaboration or the CCNP Collaboration level. It is on the CCIE Collaboration lab, however. Now let's talk just a bit more about the Cisco Unified Communications Manager Express. Already, I gave you the brief introduction to it. I said this is going to be for your small to medium-sized offices, up to around like 450 to 500 users, something in that range. And we've got our phones connected into a switch, and that switch connects into our router that happens to be provisioned. We have licensing for Cisco Unified Communications Manager. Unified Communications Manager Express. And it's going to be able to do your basic call processing, things like you would expect. Your hunt groups, your call forwards, your busy hour responses, things like that. Now, something to note here is that depending on the phone that we're using, some phones only support the session initiation protocol, or SIP. That's another term for your notes. That's a call signaling protocol. Some phones support SCCNE. SCCP is the abbreviation. That stands for the Skinny Client Configuration Protocol. That was inherited from Celsius systems when Cisco bought them back in the 90s, and the acronym kind of carried over. But some phones will speak SIP, some will speak Skinny, some will do both. But the point is, the Communications Manager Express, it will speak either one. So it's pretty flexible. It will speak to either type of phone, or both at the same time. That's valid. And it's going to allow you to set up a call between the phone. Now, before I show you the next part of the animation here, a little pop quiz. Who can tell me, once the call is set up by our call agent, what protocol is going to go directly between the phones? Doesn't have to go through the router anymore, just through the switch, directly between the phones. What protocol is going to be used to carry the actual voice media at this point? Go ahead and type that in, if you would, to the comments area. What's going to be carrying the actual voice media? Yeah. Sandeep, first one in with the correct answer. It's RTP, the Real-Time Transport Protocol. Joel and Nate also have it, and Jeffrey. And lots of people coming in with the correct answer. Chris has, Chris is not wrong. He said IP. IP is going to be carrying UDP, which is going to be encapsulating our RTP. So we're going to be able to have call processing set up by the router, and then we've got RTP directly between the phones. Now, we can also go out to the rest of the world. We can have what's called a TDM connection. Earlier on, we talked about PRI connections, primary rate interface. Those are ISDN circuits. Well, TDM, that's an example of TDM. That's time division multiplexing. That's some sort of a digital circuit, a T1, an E1, going out to the public switch telephone network. So we can go from our network out to the rest of the world, and we can even connect into another call agent. Maybe we've got a communications manager express at a remote sales office somewhere, but they can connect back into the main corporate office and talk to the corporate Cisco Unified Communications Manager if we want to do that. And the two protocols that can be used to speak between the communications manager and the communications manager express, the two protocols we're going to use are SIP and H.323. SIP and H.323. Now, something we can do inside of that communications manager express router is we can have voicemail in it. We can have what's called a Cisco Unity Express module, or CUE module. And it's a daughter board that can, or it can be a module that you plug in or you insert into your router. And it's going to have a flash storage or an actual spinning hard drive on it that's going to store your voicemail messages. So if you're a small to medium-sized office, not only do you have a call agent, you can have voicemail by using that little card. And there's different ways of configuring it. You can configure it using the CLI, or we have the GUI interface as well. Now, it's very similar when we talk about the Cisco Unified Communications Manager. We still have to have that call agent to set up the calls between our phones. This time, it's going to be a server. It's a server-based solution. And as a result, it's going to be able to scale larger. It's going to be able to support more phones. I said that we're going to max out around 500. It depends on a few things, but we're going to max out around 500 for the Communications Manager Express. But for Communications Manager Server, if it's a high-end server, one server can support 7,500 phones, 7,500 IP, if we have licensing for it, that is. And like the Communications Manager Express, it can speak to the phones using SIP and or Skinny. And then when the phones start to communicate between themselves again, they're going to be using RTP, the real-time transport protocol, to speak between themselves. Again, we can get out to the rest of the world, and we can do that by using a gateway. Oh, by the way, you see the term clustered servers on screen? Generally, in fact, pretty much always, Cisco recommends that for an installation, you never have just one communications manager server. Depending on how many phones you need to support and how many other services you need to support, they recommend that you have a grouping of servers. Now, this grouping is called a cluster. More on a cluster here, I think maybe on the next slide, or we're just about to that discussion of a cluster. But we'll talk about a cluster. And a cluster is going to allow us to share database information between our different communications manager servers. And it also gives us redundancy. So if one server goes down, another server can take over, and those phones, the phones that were registered to that one server, they can re-register to a different server. And like I said, we could also get out to the rest of the world. We can integrate with something like an LDAP directory, a lightweight directory access protocol directory. So I could press that directory button on my IP phone, and instead of having to store all the user information in my communications manager server, which I could do, I can go out and query a Microsoft Active Directory server as an example, and it can give me a listing of the people in my organization along with their phone numbers. So I can just select from. In other words, we don't need to double the work. We don't need to set up a bunch of users in Active Directory for people's email accounts and then set those users up again in Communications Manager for their voice accounts. We can leverage the same directory. Now, big point. When we're communicating between the communications manager and the gateway that gets us out to the rest of the world through a TDM circuit again, there are now 3 protocols that we can use. Now, if I've got some video training on this, and if you take the video training, I show you how to set each one of these up, by the way. I show you how to register phones and set up both of these platforms. But the 3 protocols that we have are MGCP, H.323, and SIP. You can use any of those to communicate between your communications manager and your gateway. I'll just tell you your real world tip. It seems that we're really gravitating towards SIP lately. Cisco's making a big move toward SIP with their phones, with their gateways, with lots of their solutions. So that's kind of what I'm predicting for the future. Lots more SIP, lots less H.323. In fact, the current version of the CCNA Collaboration Lab removed a huge section on H.323 gatekeepers, is what it was called. Completely removed that section. And they added some SIP stuff. So I think that tells the direction Cisco's moving. Now, I mentioned with clustering, for redundancy, for scalability, for performance, we can have more than one server in this grouping that we call a cluster. And there's two kinds of communication for your notes that happen within that cluster. I said that there's a database that gets shared between the different servers in the cluster. Now, there's a publisher server which has a read-write copy of the database. So if you make a change, if you go in and add a phone, you add a gateway, you change permissions, that change that you configured, it gets written to the publisher server. And then the publisher server is going to replicate that out to all the other servers. All the other servers are called subscriber servers. So the publisher is pushing out the information to the subscriber servers. Now that's one of the two types of communication we have. The second type of communication is called intra-cluster communication. So think of the database replication as replicating configuration information. I've configured something, it's going to be written to the database and replicated out. Intra-cluster communication is communication between every server in the cluster and every other server in the cluster. Think of this as real-time information. In other words, I go off hook on my Cisco IP phone. Everybody needs to know that. I've got a call in progress. Everybody needs to know that. That kind of real-time information gets communicated using this inter-cluster communication. I said that the communications manager server is going to be, it's kind of the star of the show. It's going to handle our call processing. There's a lot to learn about this. In fact, if you go through the CCNP collaboration curriculum, there are 2 courses just on that focus on configuring the communications manager server. I just want to share with you conceptually today how a route plan works. How do we add call routing intelligence to this communications manager server? And there are really 4 different entities that we create. First of all, if you want to take some notes on this, we can create a device. Now, a device is one of 2 things. Well, first of all, what is a device? A device gets us to a different network. It'll get us to another cluster. It'll get us to a communications manager express. It'll get us to the PSTN. It'll get us to an IP telephony service provider. It's some sort of device that gets us off of our network somewhere else. Now, I said there were 2 kinds. We might have a gateway. Now, that gateway could be H.323, SIP, MGCP, like we talked about. The other thing a device could be is a trunk. We can have a trunk connection. Again, probably a SIP trunk. There's other types available, but typically they're going to be SIP trunks these days. And we might have, let's imagine this. We've got a situation where to get between these 2 offices, to get between the headquarters and this remote office, there are 2 paths. Now, one path goes over the IP WAN. Awesome. Let's use that if we can. There's a backup path that uses the PSTN, and it's a long distance call, maybe an international call, and we have to pay for it. Rather than not do that, but kind of nice to have it there as a backup in case we need it. So we could have one device that's a trunk that gets us to, or maybe it's a gateway, but it gets us out to it gets us out over the IP WAN to that remote site, pretty much for free. Now, the other device could be a gateway that gets us out to the public switch telephone network. Okay, it's great that it's there as a backup. So we can define those two devices. Now, we put devices into a route group. So if I had a bunch of gateways that got me out to the PSTN, I could lump those together in a route group. Or I could just put one in there. I could take the trunk that got me to the IP WAN. I could put that in its own route group. And then I could take those route groups and stick those in a route list. Now, a route list is an ordered list of route groups. So in other words, I could have my IP WAN route group higher in the hierarchy than my PSTN route group. I'm going to prefer to go over the WAN. Only if the WAN's unavailable, only then do I fail back and I start using the PSTN. Then I put that route list in a route pattern, which typically uses wildcards to match some sort of a dial string. It can recognize if you're dialing an emergency number like 911, or it can recognize, if you configure it right, that is, it can recognize if you're dialing a local number, a long distance, or international numbers. So let me give you a more specific example of what I just described. Here's the topology that I had in my mind as I was describing that to you. I've got two ways of getting between the headquarters and the BR1 site. One way is over the IP WAN, one way is over the PSTN. And I've got a PRI gateway that gets me to the PSTN. I've got a SIP trunk. That's my preferable way of doing it, that gets me over the IP WAN. So I want to take my PRI gateway and my SIP trunk, and I'm going to put them in their own route group. I've got an IP WAN route group, and I've got a PSTN route group. Now, remember, I put the route groups in the route list, and I put them in order. Which one do I want to use first? I want to use I want to use the IP WAN route group first. It's free long distance or free international calls. So let's do that first. As a backup, though, I'll use the PSTN route group. It's good to have a backup. And then I'll take that route list and I'll put that inside of a route pattern, which might look like 3XXX, where X represents any dial digit. So let's say all the phones at the BR1 site have numbers in the range of 3,000 through 3,999. I could put my route list in there. So I dial 3501. Ding, ding, ding. I've got a match. So we look at the route pattern and it says, yes, that's a match. Let me hand you off to my route list. And the route list says, let's check my first route group. It's available. The route group says, let me check who's in this route group. And it's a SIP trunk. And off the call goes to the IP WAN. Pretty elegant the way that works. But again, if we had a failure on the IP WAN, let's say that WAN link between the headquarters and the IP WAN were to go down, great news. We've got a backup path through the PSTN. Now, as a real world tip for you, you might want to put this in your notes as well. We've got these four things that we configure: devices, the route groups, the route list, the route pattern. Here's my real world tip for you. You want to configure these alphabetically. We want to configure this alphabetically. DGLP. DGLP. You configure the devices first, then the G, the route group, you put the devices in the group. Then you configure the L in DGLP, the route list. You put the groups in the list. Then you configure the P in DGLP, the pattern. You put the list in the pattern. And that's in essence your route plan. Now, by the way, that's a basic route plan. If it just occurred to me, I hadn't planned on mentioning this, but I don't know if you guys attend Cisco Live, but you realize you can go out to CiscoLive.com and get a free online account, and you can watch replays from previous Cisco Lives. If you want to learn more about route plans, I presented at Cisco Live earlier this year in Las Vegas, and you can look up my session if you want to. You can search for my name, and you'll be able to watch the video of my session where I talk about this, and then I take it another step further and another step, and we dive deep, deep, deep into the route patterns. If you'd like some more free training on that, that's available out at CiscoLive.com. But back to our story. We've got this call agent that's going to be able to make intelligent call forwarding decisions. But if we take a step back, we realize before we can do any of that, the phone has to register with the communications manager server. And this is what I teach my troubleshooting students. That's the reason I have the toolbox on screen. But I thought we would use this slide to talk about the registration process. I want to take some notes on this. So the first thing is we've got our IP phone. We plug it into probably a Cisco Catalyst switch that then gets us over to the server. When we plug it in, obviously the phone's got to have power. Yes, you can go out and buy an external power supply called a Cube and plug it into your phone, and you can power your phone with the power strip underneath your desk. Please don't do that unless you have to. you got to go through the expense of getting the cube. There's a lot of different models out there with a lot of different sizes of the jacks. I've bought the wrong one multiple times, so you can tell I'm a little bitter about that. It's so much more elegant to use power over Ethernet, where you're just getting your power directly over your Ethernet leads, pins 1, 2, 3, and 6, from your Cisco Catalyst switch. So the phone, bing, boops, it starts to boot up. It's got power. Now, like a PC can do, it needs an IP address. It's an IP device. It needs to get an IP address, and it can do that using DHCP. However, something interesting going on here, we would typically set this up that it plugs into what's called a multi-VLAN access port on a switch. You see, on the back of a phone like this we see on screen, this is a 7965, there's another port on the back. There's not just the port that you plug into the wall jack that goes back to your switch. There's another port that you can plug your PC into. So in your cubicle, you've had this PC for years, and now somebody drops an IP phone on your desk. It doesn't mean you got to run another Cat 6 drop into your cubicle. You just plug your PC into the back of the phone, and then the back of the phone goes back to the wiring closet. So you're kind of daisy chaining the PC through the phone back to your wiring closet switch. But then we start to have a quality of service issue. We've got the data from your PC contending with the voice coming from your phone. So what we can do, Cisco's recommendation is you put the voice in one VLAN and you put the data in a different VLAN, and you can give them different quality of service treatments. So basically there's two valid VLANs on this port to which we just inserted our phone. How does the phone know which one to use? CDP. The Cisco Discovery Protocol will tell it. The Cisco Discovery Protocol tells it its VLAN assignment. So now the IP phone can make an intelligent DHCP request to say, hey, I'm going to need an IP address, and I need some IP address information, and I'm a member of this subnet. Because we've got two subnets on that one port, but it knows which one it belongs to, and it sends its broadcast based on that. The DHCP server replies and says, all right, here's your IP address, here's your default gateway, here's your subnet mask, and something we add on to the DHCP configuration, we say, here's the IP address of a TFTP server, a trivial file transfer protocol server. Why do we need that? That's where a configuration file lives. When we go in and we make a configuration change on Communications Manager, I update what the buttons on the phone do, I update the soft keys, or I change the permissions from the phone. That changes the phone's configuration. There's an XML configuration file associated with the phone. So what we need to do is we need to go get our configuration file. How do we do that? Well, we're going to download a basic configuration file. Most of the information is stored on the server in some cases. So we need to download our configuration file. And because the DHCP reply said, here's the IP address of a TFTP server, go get your XML configuration file. And it goes up and it pulls it down. And inside that configuration file, we've got a list of as many as 3 Communications Manager servers with which that phone can attempt to register. Hopefully it's going to be able to register with one, and then it's going to download that XML configuration file, and then we're off to the races. The phone is up, the phone is happy. Now, by the way, I've seen we have some questions coming in. I'm going to take questions here in about 10 minutes or so. Before we talk about video, we'll take a little pause, and we'll take some questions. And I've got a big thank you that I want to give you for joining me here live today. We'll hit that, I would say, in about 10 minutes or so. But first, just a few quick words about the messaging system that we get with Cisco Unified Communications. It's Cisco Unity Connection, or CUC, and that's our voice messaging solution. So you know how voicemail works. Somebody calls into my office, I don't answer, or I'm busy. The call forwards off to my voice mailbox. They leave a message, and I can go retrieve it at some later time. Now, it's a Linux appliance. It's a server, but it's running a Cisco flavor of Linux. Now, if you're a Linux guru, you're not going to be able to go in there and do a lot of change mode, set your passwords, go into your Etsy directory and do a bunch of stuff. You're not going to be using the VI editor. You're protected from the Linux kernel, I'll say. Cisco gives you a subset of commands that you can use. So don't think that you're going to have full run of the Linux operating system on there, but it is based on Linux. Now we can take this server-based voicemail system and we can integrate it with some, not all. In fact, I would even say not most, but there's a subset of PBXs out there that we could integrate with Cisco Unity Connection. So as we're taking these baby steps to upgrade to a Cisco Unified Communications Manager network, we might want to upgrade voicemail before we upgrade the call manager. In some cases, you're able to do that using a couple different types of gateways that really, I wouldn't worry too much about that for your exams, just sort of a good to know. What we're typically going to be integrating with, though, is not a legacy PBX. It's going to be a modern day communications manager server. So we're going to be able to integrate with that using, you can probably guess, two protocols, Skinny or SIP. A couple of options here. Now, remember we talked about the concept of having clustering within Communications Manager where we can have a grouping of servers. There is the concept of clustering with Cisco Unity Connection, but it's very, very different. With Communications Manager, I could have a server, and I said, depending on the server, it could support as many as 7,500 IP phones. I could add a second server, and suddenly my capacity doubles. Suddenly I can register 15,000 phones. That's not the way it works with Cisco Unity Connection. With Cisco Unity Connection, at a maximum, we could have 20,000 mailboxes. That's a lot, but we could have a maximum of 20,000 mailboxes on a server or on a cluster of two servers. Your cluster size is limited to two servers. So let's say that we did add another server and we now have a cluster. Does that increase our mailboxes? No, it does not increase our mailboxes. Then why would we want to add a server? First thing is redundancy. We want to be redundant. So if one server goes down, the other server can take over. Another benefit is that it doubles your number of voicemail ports. So when you call in and you're listening to your voicemail or somebody's leaving a message for you, you're logically taking up a connection. It's called a voicemail port. And a server at a maximum has 250 of those. Well, by having two servers in your cluster, suddenly you've now doubled that. Now you've got 500 ports at a maximum. So it's going to give you scalability. It's going to give you redundancy to do clustering. Couple of ways you could do clustering. You could interconnect your servers using something called an inter-site link. Now, by the way, that is only supported with Cisco Unified only supported with CUC. It's not supported with some third-party voicemail system, only with Cisco Unity Connection. Another option that is more vendor interoperable. In fact, remember earlier I said that within a router, we could have a voicemail system. We could have a Cisco Unity Express within a voicemail system. If you wanted to connect between a Cisco Unity Connection, a CUC server, and a Cisco Unified Communications Manager Express router that had that Unity Express module in it, there's a different protocol you could run called VPIM that actually sort of uses mail. Uses mail to do that. Uses mail to send those messages back and forth. Now, we've got some different types of call routing with Cisco Unity Connection. Because think about it. Sometimes when you call into this voicemail server, it says like, welcome to company XYZ. Enter your PIN to listen to your voicemail messages. So if I pick up my desk phone and call into the system, it knows it's me because it looks at my caller ID. It knows it's me calling in, and it prompts me for my PIN to enter to get my voicemail. But sometimes if you call me and I don't answer or I'm busy, the call goes again to the same server. But this time it doesn't say, hey, enter your PIN to listen to your... No, it says, hi, this is Kevin. I'm unavailable to take your call at the moment. Please leave a detailed message and I will call you back if necessary. We got different messages, but we called into the same system. Why is that? Well, there's two basic types of call routing here. We've got direct call routing, and that's when I'm calling directly into the system. That's where it's going to prompt me to identify myself so I can listen to my messages. The other option, the other type of call routing is forwarded call routing. So it goes to my phone, and again, I'm busy, I don't answer, or I can have a soft key button that just says, I'm busy, just send them to voicemail. And it goes directly to voicemail. That forwarded call routing, that is going to prompt you to leave a message for me, because when my phone extension 2002, when I forward that to the Unity Connection server, it's going to include my information. It's going to say, by the way, this is coming from 2002. And it's going to say, oh, okay, I'll send it to their voicemail box as outgoing message. So that's another look at how Cisco Unity Connection can kind of creatively use call routing. And when you hit the server and you hear some sort of feedback, you hear some sort of announcement, those are made possible by something called call handlers. There's like the system call handler. You just call in and says, welcome to company ABC. If you know the party you're looking for, press this. You can have kind of an automated attendant running here as well. Or if you're just calling in to get your own messages, that's a system call handler. You could have a directory call handler where you call in and it says you can dial by name or dial by number the person you're trying to reach. And it will be able to, oh, you're trying to reach so-and-so? Great. We'll contact you with them. Or there's even an interview call handler. Imagine this. You can send out a poll to your organization. If you're trying to figure out what lunch we should have on Wednesday in the cafeteria, you could say, tell us what type of food you would like to see in the cafeteria on Wednesdays, and how much would you pay for it? And it could ask a series of questions, and then it could record the responses from all these people. Pretty amazing. So I've got all that stuff going on. Now, I hit the wrong button. I hit the back button. Sorry about that. So let me quickly click through these. So we just saw all this. Went back to the previous slide. Now, real quickly, and then we'll take a Q&A break, and I'll tell you about that. The thank you that I've got for you for showing up today and joining me on this kind of a spontaneous Facebook Live session. The Cisco IM and Presence server, it can actually do a few different things, and I want you to understand what protocols are in use here. One that I told you about earlier is presence information. I'm on my Jabber client, or I'm on my phone that has the LED lights, and I have you as a speed dial perhaps. I can see if you're busy or not. I can get your presence information. Now, the way that's possible is when the communications manager server sees that you're on the phone, it's going to send a message over a SIP trunk up to the IM and Presence server to say, hey, Bob's on the phone right now, so we're going to turn your light red or yellow or whatever we're going to turn it. And that way I can look and say, oh, Bob's not available for a call right now. I'll try back later. Now, by the way, I said we're going to use a SIP trunk here. SIP has a very unique ability to carry presence information. Our other trunks don't. SIP's pretty cool. It can carry presence information, and it's the only thing that can carry presence information. Something else we can do with the IM and Presence server is we can have it, well, it supports our software-based clients as phones. Remember I mentioned Jabber earlier? We can actually use that as our phone. It could be running on our laptop. It could be running, I installed the Jabber client on my iPad. I installed it on got the new iPhone 10, pretty proud of that. But I installed it on my iPhone, and I'm able to make phone calls. I'm able to talk to the communications manager and make phone calls like my phone or my laptop was some sort of a Cisco IP phone using the Jabber client. Now, this only speaks SIP. It's not going to support Skinny, but I'm going to use SIP as my call setup protocol, and I'm going to be able to call somebody else, and then the RTP session is going to be set up between us, like we talked about earlier. Something else we can use the Cisco IM and Presence server for is I could control my desk phone. So in other words, maybe I'm a customer service rep, and I don't want all day long to be reaching for the handset. Hello, customer service, may I help you? Hello, customer service, may I help you? No, what I can do instead is I can just wear a headset. I've got a headset over here. I can just put that on, and I could have that plugged into my laptop, and I could communicate between my laptop, my Jabber client on my laptop, and a physical phone on my desk, as an example. And my desk phone starts ringing. I can just take my mouse and click, and suddenly I'm talking through my headset. I'm able to control a desk phone call through software. Now, there's another protocol we haven't mentioned yet that controls that. So here's another told you there'd be a lot of acronyms today. Another acronym is CTIQBE. That stands for Computer Telephony Integration Quick Buffer Encoding. That's a mouthful. Just make a note that allows software to control your phone. You can answer calls, you can place calls on the phone remotely through software. Now, what else can we do with the Cisco IM and Present server? Well, we can do instant messaging. That's what the IM and Present server means. The protocol that we're going to be using for that is XMPP. I think that's Extensible Messaging Presence Protocol. It's kind of a derivative of XML. It's kind of an extension of that can support messaging and presence information. What else can we do? Well, we could actually reach out and get voicemail information. Believe it or not, we could. It's kind of like an IMAP client. If you get your email via an IMAP client, you know that your computer goes out to the server, and using IMAP, it shows you a directory of emails that you have, and you can open up selected emails. It's going to retrieve it to your device. That's what Jabber uses. Jabber can reach out to our Unity connection server, and it can say, give me a listing of voicemails that I have. And it's going to say who the voicemail is from, the time it was received, the duration of it, and you can play it through a little graphical interface. You can click the play button, and it's going to play back the voicemail because it retrieved it via IMAP. It's going to play that back using something like your Jabber client. There is one other server that I should have mentioned. Much like the Communications Manager server, we can do a directory lookup using LDAP. But I want to give you a thank you for joining me today. So if you'll permit me for a moment, I'm going to run a little test. You guys are my little test group. I'm doing some price testing on some of my courses, and as a huge thank you, I'm going to give you a never before discount thing. So follow me on this, and this will be for some of you. It won't be for all of you, but here's what I got. I've got a. In fact, if we go over to Cisco's website and we see what does it take to get your collaboration CCNA, well, you've got to take these 2 exams, and there are Cisco Press books that I recommend you go get to study for those 2 exams. But there's a lot of hands-on experience you need. You need to see some stuff being set up. You need to understand the concepts as I've been explaining them today. So what I did, I allow you to kind of look over my shoulder in this CCNA Collaboration video training series. I've got 25 videos. It runs about 7 hours, and you see me set up a bunch of stuff that's talked about in the CCNA Collaboration curriculum. And I've been selling that for a little while now for $197. Sold a bunch of them. Similar for CCNP, I've got 22 videos, and again, it runs about 7 hours. I sell that for $197 also. If you look at the CCNP curriculum, what does it take to earn your CCNP in collaboration? It's there are 4 different exams. So what I do, I recommend you go get the Cisco Press books for this, but to help you out with your labs, your hands-on studies, you can just look over my shoulder with these videos. And what you can do is I created 5 videos for each of those 4 courses. So you can watch me go through those. And I've sold that for $197. And then for those that are going to the CCIE level, I've got a CCIE product. It's a complete lab walkthrough. I created my own mock lab, and it's more than just walking through a lab, which we do, but it's strategy. It's how you approach your lab day. Some time-saving tactics. Time is your enemy on the CCIE lab. How to troubleshoot effectively. And I take 16 videos and walk you through an entire lab day, just as you would do it on lab day. And I include some bonus videos. The current version of Communications Manager on the CCA lab is 9.1. So these are shot on 9.1. And I include a series of videos that show you new features and therefore more likely to be asked on version 9. I include a 300-page plus printable PDF that gives you screenshots of everything you're doing. You might think, well, CCIE isn't for me. I'm just getting into this. Well, here's the cool thing about the collaboration curriculum. It's all pretty much the same. Well, I mean, with the exception of UCCX, you're studying the same stuff at each level of your certification pursuits. It's just at different levels. So all these do a beautiful job of complementing one another. And I sell that for $297. But then I thought, okay, if somebody wants to just go all in on collaboration, I'm going to let them get a bundle. I'm going to save them a couple $100 for doing this. I'll give them the CCNA. I'll give them the CCNP. I'll give them the CCA curriculum. I'll give them that bonus 9 for 9 series. I'll give them the 300-page guide. I'll even throw in 40 extra videos. So I've got 12 extra feature videos that I throw in and 12 extra videos on quality of service. And I say, I want to drop the price by like $200 if they just do the whole thing. So I've been selling this for $491. People love that because they get pretty much everything when it comes to collaboration. But like I said, I want to use you guys as a little test group today, just doing some price testing. But let's take a look at an overview of video networks. No longer do we just have video calls or voice calls that we're placing between our phones with audio only. We can now have video calls because a lot of our phones have cameras built in, or we can add on cameras, and they have different types of resolution. But some examples of video applications, this is like a big conference call where you've got these big 60-inch screens that you see on the wall, and it's really immersive. I'm telling you, the first time I used one of these, it was kind of freaky. I was in, I don't know where I was, but the other person was in Austin, Texas, and it was like I was talking to them directly. It was pretty amazing. We can have, if you have really high tier contact center support, I know a lot of companies, they want to have a premium experience for customer support. So you could even have, think about that, calling into tech support and having somebody talk to you over video. That would be pretty cool. For video surveillance, Cisco has a series of video cameras that you can use for video surveillance. These can use power over Ethernet also, by the way. So yeah, a lot of applications for video, but I want to help you understand some of the video concepts so you'll be able to work with this. So get ready to take some notes. We're going to camp out on this slide for a while. The first term I want you to know is FPS, or frames per second. Now, I mentioned earlier that when I go see Star Wars, if it's like most traditional theater movies, and they might do something else because after all, it's Star Wars. Oh, somebody said, how much for that boot camp? It's free if you're part of the Safari Books Online. If you're not, join for $39 and then cancel after a month. So $39 at a maximum, but maybe free. All right. See, somebody facing an issue with video calls that's going into preservation mode. Yeah. I've run into a lot of video call issues as well. I have spent days trying to figure out one problem. There's not a quick answer I can give you there. Just the quick answer is open up a TAC case. Hopefully you've got maintenance, open up a TAC case, and they can help you out with that. There's no, oh yeah, I bet I know what's happening. Try this. It's there's a lot that can go on with video calls. But back to our terms. Frames per second. If I'm watching Star Wars, they're projecting 24 frames every second up on the screen, but because they're playing in rapid succession, let me see if I can turn my video camera back on. I'm giving all these gestures and I realize, hey, nobody's seeing that. but if I'm projecting these 24 frames up on the screen and they're flying by in rapid succession, it looks like smooth motion. But let's think about this. If I just had my little film strip, and let's say here's my light, and I'm just running this film strip in front of my lamp, if I just steadily ran that film strip in front of the lamp, it's going to be a big blur, isn't it? I mean, we have to stop and project an image, and then we have to bring it down to the next one and project an image. It's going to be a blur as I'm moving across that lamp. So what happens? Well, in front of that lamp, inside of a movie projector, we have a shutter that comes down in front of the lamp, and that shutter is going to block the light as the film advances to the next frame. And how often that happens is called the refresh rate. So imagine this. We've got our movie projector and it's moving the film through. It's going to project an image. It's going to drop the shutter in front. It's going to move to the next image. It's going to drop the shutter in front, and so on. Now, that would be if I had a refresh rate. Refresh rate is how many times we're showing an image. So with a projector, it will be the number of times that shutter comes down every second. if I just had a frame projected and my shutter comes down, I move to the next frame, my shutter comes up, and so on, that would be a refresh rate of 24 to match the 24 frames per second. There's a problem with that, though. That doesn't really look good, because we're going to start to notice those little gaps. There's an image, and then there's a flicker, and now we're going to see kind of a blinking on the screen, because there's going to be a period of time where we're looking at the image and a period of time where the shutter's in front. So it just looks kind of jumpy. Doesn't look right. So what we often do is take the refresh rate and double it or triple it. We could double the refresh rate to 48. So now we're showing an image, one of the 24 images we're going to show a second. We drop the shutter in front of it. We move the shutter up. It's the same image. We drop the shutter down again. We move to the next image, and we show that next image twice. You see, we're refreshing 48 times a second. That shutter is opening and closing 48 times a second. And because that's more consistent, rather than just doing it every 24th of a second, we don't get that jumpiness, that little flicker that we would have otherwise. If we had a refresh rate of 72, then we will be opening and closing that shutter 3 times for every frame. Now, how does this relate to video that we're going to be doing? Well, you might have heard of interlaced video, like 1080i. I remember like the first quote unquote high definition television that I ever got was 1080i. And that was 1080 interlaced. Now, interlaced TVs, they don't really have the bandwidth to support refreshing the entire screen every refresh rate. So here's what they do. Let's say on video, typically our frames per second is more like 30 instead of 24. So a lot of high definition TVs out there, they have a refresh rate of 60 hertz. So in other words, for every frame, that frame is going to be refreshed twice, kind of like the movie projector example. Now, what if we played this little trick? I've only got enough bandwidth to send 540 horizontal lines during each of these 1/30th of a second periods. Actually, during each refresh rate. Let's say I've only got enough bandwidth to simultaneously send, I can only simultaneously send 540 lines. I'd like to send 1080. I'd like to send double that. What if I played this little trick? What if during the first refresh rate, I send half of those lines? Every other line, I've got enough bandwidth to send that. I'll send half of the lines during one refresh rate, and then during the next refresh rate, I'll send the other half of the lines. And that's going to give me the complete picture. That's kind of tricky, isn't it? But it works. That's a way to kind of sort of get 1080 horizontal lines of resolution when you really don't have enough capacity to support painting 1,080 lines every single refresh rate. So we were showing the same image twice anyway. Why not just show half of it and then another half of it, and then suddenly it's a clear image? Now, yes, it is going to be a bit more blurry because we're not repainting everything every refresh cycle. It's going to be a little bit more blurry than what's called progressive video. With progressive video, we've got the resources available where, yes, we can send the whole thing. We can send the whole thing. And that's where we get 1080p. 1080p means progressive video. 1080i means interlaced, where we're playing those games with the refresh rates. Another term for you to know is pixel. Now, a pixel is a picture element. If you think of like a 1080p HD TV, you've got 1,080 horizontal rows, and you've got 1,920 columns. And the intersection of a row and a column, sorry, I just hit the microphone, that's a picture element. And that's the smallest unit of data that makes up our picture. A pixel is a picture element. And of course, the more pixels we have, the clearer the picture is going to be. Just to give you an example, I've got a couple of iPads. I've got an iPad mini, and then I've got the iPad Pro that I showed you a moment ago. Now, the iPad mini, I zoomed in, or I took a screenshot. There's the music icon, And depending on what your resolution is set to in Facebook right now, hopefully you set it to HD. But depending on your resolution in Facebook right now, you're going to be able to see some little jaggies, some pixelation going on with the music icon on the left. But on the right, it's much, much smoother because that uses what Apple calls their Retina display. That's where you're not supposed to be able to discern pixels when you're looking at something from a normal viewing length. So that is that's a higher resolution. So the more pixels, the clearer the image is going to be. Another term for you to know is the aspect ratio. That might be something you have to set up in your video conferencing configuration. Now, a common aspect ratio for years was on the old. Anybody have an old TV like this? It kind of looks like my first black and white TV I had when I was a kid. But the aspect ratio is the ratio of the vertical columns to the horizontal lines. So this TV right here, it's going to have an aspect ratio of 4:3. The vertical distance, colon, and then the actually I said that backwards. The horizontal distance, colon, and then the vertical distance. On most TVs today, though, you go out and buy an HD TV, it's probably going to be a 16:9 ratio. It's going to be more. Wow, keep hitting the microphone. Because that's more like you see it in the movies. Movies are a little bit different than that, but I mean it's wider screen. Are you like me? Here's a pet peeve, just on a tangent. Does anybody have a pet peeve with vertical videos that people take on their iPhones? They take the vertical videos and you waste all this space on the edges. And I'm saying, no, don't take vertical videos. You want to do horizontal or landscape, because think of the human eyes. The human eyes are side by side. We see in landscape. Please stop taking vertical. Okay, off my soapbox again. Done that a couple times today. Yeah, on a side note. But we've got 16:9 ratios on a lot of our HD TVs these days. So that's called a 16:9. Now, more recently, we've seen 4K TVs come along. So here, with if I've got a 1080p TV, that means I've got 1080 horizontal rows. I've got 1920 vertical columns. If you multiply those together to determine the number of pixels, it's about 2 million. But with a 4K TV, the number gets weird here, because normally if we talk about 720p or 1080p, the 720 or the 1080, that's talking about the number of horizontal rows. 4K is not talking horizontal. It's talking about the number of vertical columns. So basically we're going from about 2,000 columns to about 4,000 columns. And we're also doubling the rows. We're going from about 1,000 rows to about 2,000 rows. So if you do the math there, 4,000 times 2,000, we're going to have about 8,000 pixels with a 4K TV. Now, there are some standards I need you to know, some MPEG standards. Now, different people will tell you MPEG stands for different things. Some people will say it stands for the Motion Pictures Experts Group. Some people will insist that it stands for the Moving Pictures Experts Group. Not a big deal, but again, I've got a bunch of pet peeves. I'm personally a Moving Pictures Expert Group guy. That's my camp. Now, back around, I think this is from the top of my head, but I think it was 93 is when the MPEG 1 standard came out. And it supported, the video quality was about like a VHS tape. Not great. Not even broadcast quality. But before we downplay it too much, I should let you know that the MP3 standard that you might listen to your music on, that's actually a subset of MPEG 1. And the reason I say that is the 3 does not stand for MPEG version 3. The 3 stands for something weird. It's like audio layer 3. It has nothing to do with the version. But MPEG 1, 1993, I think 1995, MPEG 2 came out. It gave us broadcast quality. It did better compression. It looked like a TV show that wasn't high definition. There was an MPEG 3 briefly, but its features kind of got rolled back into MPEG 2 and it disappeared. But I do want you to know for the real world today about MPEG 4. This is a big deal today because MPEG 4, one of its standards is H.264. That's what a lot of our Cisco IP phones are going to be using. A lot of our TelePresence systems are going to be using those as well. And specifically, we're going to be using MPEG 4 AVC, which is advanced video coding. So H.264, that's a very, very popular video codec that we can use. It's used on Blu-rays. It's used on Blu-ray discs, and we can use it on a lot of our phones. Now, some of the new the very, very recent telepresence systems, they now support an enhancement to that. Don't think you're going to be responsible for it on the exams, but there's an enhancement to that called H.265. So just be aware of that. Now, I'm not going to spend much time on these next few slides, and we'll get to our next Q&A discussion here in just a few moments. I just want to give you a sense for some of the different video endpoints that are out there. I'm not trying to teach you a bunch of configuration here. I just want you to understand what Cisco has available. They've got IP phones. They've got desktop endpoints with bigger screens. They've got software-based clients like your Jabber clients. First, let's talk about the 8800 series phones. I don't have one of these. I wish I did. These are the ones that you're starting to see in the movies and the TV shows. Used to see the really old Cisco IP phones. These are the ones you're starting to see these days, even in offices. I went to I had to get some work done at the hospital recently, and I think it was one of these phones or one very similar to this behind the desk. So these are very, very popular today. The video resolution isn't bad. It's 720p, but I mean, 720p squeezed down to a 5-inch screen, that's going to look really, really, really sharp. I mean, we're not talking about a 40-inch screen, so it's going to look really, really sharp even at 720p. And it's using that H.264 codec that we were talking about. Now, the one on the right, the 8865, it can connect wirelessly, and it's even got a little USB port where you can charge something. So it's got a couple other bells and whistles. And kind of at the low end, if you want to have a video-enabled phone, but you don't want to spend a lot for it, one of the kind of the entry-level phone, you've got the good, better, and best. Well, this is the good phone, the 8945. It's got less resolution. Now, by the way, the previous phone, it could only run SIP, I believe. This one can do SIP or skinny, but it's got a 5-inch display as well, but it's only going to be VGA graphics support. Daniel says, Daniel's got the 8841 and the 8851 phones in his office. I'm envious. I'm envious. If you want to say thank you for this webinar, you could send. No, I'm just kidding. I'm just kidding. But yeah, I'm envious. That's awesome that you have that. Now, here are some of the older phones. Now, one reason I wanted to show you these is if you are going after the CCNA Collaboration lab, these phones are on the lab as of today, and they will be for the next few months anyway. They are video-enabled phone. Well, the 9971 on the right specifically, that's what Cisco says is on the lab. And you don't have to have video support here, but you see the little video camera sticking up above it? I've got one here. Here we go. Here's the little video camera that we've got. See, it's got a USB port at the bottom. There's the camera, and we can twist to open and close the shutter. So that just sort of plugs in behind the phone, and that adds video support for your phones. Yeah, Daniel says, yeah, cut my teeth on the 7900 phones. Me too. Me too. I've got a storage room in my home full of them. Actually, I think I might have thrown them out, a lot of them. But yeah, I'm in the same shape you were. Now, besides these video-enabled IP phones, well, and I'll just put some of the specs up here. I don't expect you to memorize these, just to give you a sense. We've also got these desktop collaboration endpoints. Now, these are devices with big screens. I mean, if you're going to be doing a lot of video conferencing, you might not want to look at a 5-inch screen all day long. You could look at like at one of these. We got like a 21.5-inch display, or at a higher end, we've got a 24-inch display. That's a comfortable viewing size. I mean, that's going to start to feel pretty immersive right there. And we can even do true HD on those types of devices. Now, there's another series of desktop endpoints called the DX series. And what makes this so special is you see the video display right there? It's running the Android operating system. It's touch screen. It's like a tablet really mounted to a phone. And it's got HD quality video at 30 frames per second. It's wireless, And because it's running the Android operating system, you can go out to the Google Play Store, you can download Angry Birds, and you could play it on your, probably would be frowned on by management, but you could do that. You could install games and all sorts of Android apps right on your phone. So that's kind of nice. Now, I was talking earlier about the Jabber clients. We've got these software-based clients, and there's all sorts of clients. We've got the clients for Microsoft Windows, for Mac, Apple Mac OS. We've got it for iPhone and Android phones. There's another one just for iPad. Now, let's talk about the kind of the big systems, these big immersive systems, the TelePresence endpoints. Now, the TelePresence endpoints fall into three basic categories. The first one is the Cisco TelePresence system, the CTS. Then we've got some desktop endpoints, and then we've got something that Cisco kind of inherited from, they bought the company called Tandberg, which have been doing a lot of the video stuff earlier. They acquired some stuff from them, and that's the TC series. So just some quick looks. Don't want to keep hold you up on product information, but I remember this one fondly. This was like the first one that Cisco came out with, the CTS 3000. This came with furniture. You see those tables there? It comes with the tables because they're trying to create the optical illusion that you're sitting at this oval table with people in other locations. So they've got these 60-inch screens strategically mounted, and it looks like they're sitting across from you on this oval conference table. It's kind of a neat idea, but probably extra. You probably don't need that illusion. And if you want to set this up, there was a course about how to set this up. There's all sorts of electrical requirements. There's all sorts of HVAC requirements for the room where you're going to put this. There's a lot of construction requirements. You don't just buy this and stick it in a room. It had a lot of things to check off, but it's currently end of sale, so we don't need to worry about that one. An update to that is the TX9000, where we start to get some larger monitors. We can still do 1080p. Now, here's kind of my favorite. Obviously, the new one probably is going to be my favorite, the IX5000. Now, this one, you're able to run a TelePresence client on your laptop or your tablet, your smart device, and you can see people's video on there. You can like draw there on your laptop and project it on one of the screens as your TelePresence system. And one of the big benefits here, this does not require any special HVAC requirement. It doesn't require a bunch of electrical rewiring. It can go in just about any room. So pretty nice. And they got away from that illusion of trying to make you think you're in the same room by the time. I mean, it's a cool look when you first see it, but then it's a little cheesy, I think, after a while. But anyway, that system's end of life. But this is kind of what the big deal is these days. 70-inch monitors, 4K, not 1080p, 4K cameras. You can tell if somebody needs a shave. And this is the one that I was telling you about earlier, that this is now supporting an even better compression, H.245. So again, we've got some desktop endpoints. We've taken a look. There's the Android. There's the standalone with the bigger screens where we can have these telepresence-like conversations directly from our desktop. And if you want to provide your own TV, you might think, I don't want to have to buy Cisco's 70-inch TV. I'd rather go down to Best Buy and get my own, or buy one from Amazon. Well, you can do that. You can do that with the SX series. We'll talk about these other series, but with the SX series, you can buy just the camera and the TelePresence engine. Now that thing that looks like a router there, the SX80, that's a TelePresence engine that you can plug in cameras, you can plug in monitors, and you can have a very large-scale TelePresence installation if you're willing to provide the the monitors. Now, we've already talked a bit about the TC-based software endpoints. These came from Tandberg that I mentioned earlier, kind of inherited down from them. I would say I told you that my favorite TelePresence system with the big screens and all that. But if I were buying one for a small to medium-sized company, I'd recommend this. I'd recommend the TC series. Also from Tandberg, by the way. The technology came from Tandberg. This is mobile. It's a big screen, but it's on a stand where you could put it on a dolly and or have an intern carry it on the back, I suppose. But you can move it from one room to another. You could have either a single screen, or you could even have dual screens. I mean, these size screens, like 42 inches, 55 inches, and here are some looks at the dual screens that we have. So those are some of the video endpoints that Cisco has. Now, as you go through the CCNA and the CCNP curriculum, You learn a lot more about the background behind telepresence. You learn about the servers that support telepresence, more detail about that. But for today, I just wanted to give you a sense for what it was like to work in this collaboration space and talk about what's going on with voice, what's going on with video, what are the pieces and parts, what's some of the theory involved.